chapter 4 and chapter 5. The reason I do chapter 4 and 5 last because this Greek is countable. The previous chapter 6, 7, 8, 9, and 11 are continuous. You need table and formula. This one, mostly we don't need formula or table at all. Alright, some of you love it, some of you hate it. But let's look at the first one, the basic concept of probability. So let's go over the notation first. If I have P parenthesis A close parenthesis, this is represent the probability of event A. Alright, you have an event A. And the probability of event, any event is going to be greater than or equal to 0, less than or equal to 1. If it's equal to 0, it means it's impossible. If it's equal to 1, it means for sure it would happen. For example, if you toss a dice, it's impossible to get a number 12, right? Because we have only number 1 to 6, so it will be 0. For sure, it will be happen, so it's 1 or 100%. All right, P parenthesis A bar is mean probability that event A does not happen. And if you have probability of A is gonna equal to 1 minus probability of not A, right? And I put a little note here. If you get any probability about 5%, it mean 5% or less. It mean it's unlikely that's gonna happen. So when they say the chance of raining tomorrow is 5%, it means most likely it's not gonna happen. All right. Now let's look at this one. I have the formula, but you just you can just pretty much reason it out. Probability of equally likely outcome. So what is probability of equally likely outcome? It means chance of each event is the same. For example, if you flip a coin, you have two possible outcomes. Chance of getting head, it should be equal of chance of getting tail unless it's not a balanced one. If you throw a dice, chance of getting number 1, 2, 3, 4, 5, 6, it should be the same. It's about 1/6. So the formula is F over N. F is the number of way that A can happen. N is the total possible outcome. So you have to list all the possible outcome and then list all the number of way that F can happen. And then the probability of that particular thing that you're looking for is F over N. Alright, so let's look at the first example. It says find the probability that a couple have 3 children, alright? 3 children, they have exactly 2 boys. Exactly 2 boys. Assume that boys and girls are equally likely outcome. It means chance of having boy is the same as chance of having girl. And the gender of any child is not influenced by the gender of any other child. So first, because it's equally likely outcome, we can use this formula here. Alright, I'm gonna use the formula. So we have to list all possible outcomes. So let's say order of a child matter. For example, if you have 1 child, you can have the first one is a boy, or second one is a boy, or third one is a boy. So it's matter. Alright, so let's say the first child. You're gonna have a first child. Alright, the first child, you have 2 options. You can have either boy or girl. So you can have a boy or a girl. There are 2 possible outcomes, and it's equally likely. Alright, after you have a first child, you're gonna have a second child, or this couple are gonna have a second child. Regardless of what you have the first, because it's not influence of each other, the second child you're still gonna have either boy or girl. If the first one is a girl, the second one still can have either boy or girl. So that's the second one. Now they can have the third child. Regardless of the first and the second, the third still gonna be boy or girl. So let's say the first one is a boy, second one is a boy, the third one still can be boy or girl. If the first one is a boy, second one is a girl, the third one still can be boy or grow. Same thing. Alright, so I'm just gonna write all this. So basically, to have 3 children, there are 8 possible outcomes. So let's follow the arrow here. You can have boy, 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 which mean all of them are boy. So boy, 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 alright? Or you can have boy, boy, girl. Next one, you can have boy, girl, boy. And then boy, girl, girl. Guess you have an idea, so I'm just gonna list everything here just to save the time. The next one, you're gonna have girl, boy, boy. Girl, boy, girl. Girl, girl, boy. Girl, girl, girl. So at 8 possible outcome. Alright, 8 possible outcome. Now the question is, find the probability when a couple has 3 children, they will have exactly 2 boys. So we're looking for probability of exactly 2 boys. Exactly 2 boys. So we don't care which order. Alright, exactly 2 boys. Is this one, that's 2 boys. That's 2 boys. That's 2 boys. So is F is number of way A can occur. My A here exactly 2 boys. So number of way A can occur 1, 2, and 3. Out of total possible outcome, 1, 2, 3, 4, 5, 6, 7, 8. 8. So I think it's about 37.5%. Let me double check. Yeah, 37.5. Alright, let's look at the next example. Hi everyone, let's look at our last example of chapter 4.1. I have a table here. So sometimes if they don't give you the table, you can draw a tree diagram like I showed you the last example. Sometimes they can give you a table. So let's look at the table here. The result from drug test for job applicants. Alright, so I have this 2x2. Subject used drug. The first cell, subject used drug, and the test is positive. There are 45 of them. Now subject used drug, but the test is negative. There are 5 of them. Subject does not use drug and the test come out positive is 25, and this cell is for 180. And the one in the box here, I add the row, alright, and add the column and so on. But let's look at the meaning of this cell. The first cell here, subject used drug. So he used drug. So the test should come out positive. So this is true positive. Now the second cell is represent subject used drug, but the test come out negative. So that is false negative, right? Look at this cell, it means that subject does not use drug. He didn't use drug, but it's turned out positive. So it's false positive. And this cell represents subject does not use drug. So he didn't use it, so it should be negative. So it is negative, so it's true negative. Alright, so that's the meaning of each cell. So if I add all these horizontal, I got 50. It means everybody that use drug that test both positive and negative. This whole row I add 25 and 480, I got 505. This represent everybody that's not use drug, but it take out most positive and negative. Now on the vertical, this is all positive test result, both use and not use. This is all negative result, both used and not used, and everybody is 555 people that we test. All right, so you make sure that you understand each cell, what is represent and how to calculate it. So let's look at the first question here. They ask you to find the probability of selecting someone who get result that is false negative. False negative is mean it's negative but he take drug. So subject take drugs but it turned out negative, so it's this one. So it's 5 out of everybody, right? There's 5 of them. So 5 out of 555. So if you convert this to decimal, it's going to be 0.009, all right? Or if you convert to a percent, it's going to be 0.9%, which is less than 1%, all right? It's less than 1%. Who will suffer? So the suffer would be, what is this? False negative. So he take drug, but the test turned out negative. So the one that suffer is the employer, because the employer think that he didn't take drug, but he really take drug. So the one that suffer is the employer, right? So this one is the employer suffer. Because basically you hire someone that taking drug. But what is the probability of that happening? Less than 1%. So chance of that happening is less than 1%. Remember we're talking about 5% is unlikely. So this is not even 5%. Yeah, less than 1%. Let's look at the second example. Find the probability of selecting someone who got a result that is false positive. False positive is mean he did not take drug, but it turned positive. So he did not take drug, but it turned positive. That is what? 25, yes, right here, 25. 25 out of everybody, which is 555. Is 0.045 or 4.5%, right? About 4.5% that happened. So who will suffer? This one false positive. It means the test come out positive, but he didn't take drug. So the applicants, right? The applicants pay for this because he did not take drug, but it come out positive. All right. So applicants. And chance of that happening is 4.5%. All right, let's look at the next example or next section. We're done with this section.